Yeah, so it may not be always stored in file system kind of storage. It can be in memory as well. It can be some specific structure also, right? So that is not something which makes it NoSQL. Uh, the second thing is, again, it may not be always a document type of format in which it gets stored. It can be key value pair, it can be graph, it can be something else as well. Different formats exist for storing the data for NoSQL databases, right? So format and the way how it is stored is not important when it comes to NoSQL. So anything else that you would like to add on this? Okay, let me make the question simple. Where do you see the use of NoSQL databases? In what kind of applications you prefer it?
A kind of reporting or maybe read-only data.
Okay,
API use.
okay.
Data is basically stored in an object, so which makes it easy to write in few
Yes.
cases, and few cases it's easy to read. I think in Cosmos DB it's not easy to read it, but it's easy to write. You could directly save the API into the as a form of database.
Yeah, but when it comes to writing, you said it is easy, but not the same case with reading. But when I'm storing the data somewhere, I'm going to read it as well, right?
Yeah,
So on what
so
basis I'm going to choose NoSQL?
NoSQL, if it is Cosmos DB APIs, it's read easy to write. That's what, and read would
Mm-hmm.
be again, I think, based on the SQL statement. But MongoDB and all, where NoSQL is stored as an object, it's easy to read, right? You could get the whole data in the form of object and then run for loop on top of them.
Okay, so if I talk about SQL Server or Oracle or any other RDBMS for that matter, do you think there we don't have easy reads and writes and the mapping to the objects and all?
Yeah, it's there, but obviously, we need to transform JSON data into the SQL table format. Then only we could save it.
Yeah, but for that we have got object relational mapping tools already.
Yeah.
Like in .NET, we have entity framework which does that job for us, right?
Yes.
And pretty easily.
Hmm.
Why would I go for NoSQL database then?
No idea then.
Anybody else? So probably we need to understand what are the limitations of our DBMS database. And uh, we'll first focus on the name NoSQL. NoSQL stands for not only SQL, and where SQL refers to RDBMS features, not SQL Server precisely. It's in general RDBMS, and most of the RDBMS use SQL query language for retrieving or updating the data. That's why the term SQL has been used here as NoSQL. So what do we mean by NoSQL over here? Now here we need to understand how the data actually gets persisted into RDBMS databases. In case of RDBMS databases, you persist all of your information always in the form of rows and columns. Am I right? It's a two-dimensional structure always.
Yes.
Yes.
And the column definition defines what kind of data is going to be stored. Where again, each column has got its own data type as well. Am I right?
Yeah.
Okay. So this is where the limitation basically starts. You always analyze all of your information that is going to be persisted into a database, and then uh, you probably go for uh, highest common factor on that particular data, and then you design your table in a way that it accommodates all the information in the form of different columns. Now here what kind of limitation we face is we may not have the data for most of the columns for most of the rows, right? Some rows may have data for some columns, some other rows may have the data for some other columns as well, right? And in that case, there would be too many nulls into our database table. And when we have too many nulls, the indexing probably may not work properly. At the same time, because of indexing not working properly, the querying of the data might get affected as well. As I won't be able to optimize my indexes, I won't be able to optimize my queries because of too many null values. And at times, I may have a requirement that if this field exists, this field is mandatory for that particular table. And some row may not have the value for that particular field. So I have multiple issues regarding the RDBMS storage. Besides all this, I have one peculiar issue over here, that is like if I'm having the variety of data coming in, various types of information coming in, like sometimes it is typical data that can be represented as columns and rows, but sometimes I may have some data which is binary and that represents some images or documents or maybe videos or audios or something like that. Discrete type of information I'm getting into my application, and that's where I may have limitations. How comfortably we can store this discrete information into a typical RDBMS database. Suppose I have a requirement where I need to take in the input in the form of rows and columns, but along with that, I want to store some binary information also that represents either the documents, PDF, Word, Excel, anything that might be representing some video files, audio files, images. How do you manage this within a typical RDBMS system?
So sometimes we use blob as a data type, and sometimes we store the address of the CDN, and we will retrieve the data from the CDN by taking the reference from the database.
Correct. So these are the two ways. First is the blob data type. Most of the databases are now supporting that. And the second way is like storing the address of that file in one additional column. That could be a CDN address, or that could be a local file system address also. Right. Now, here also we have some limitations. When we go for blobs, how many blob data you can have in one single row?
I think one.
Only one column of type blob is allowed. What if I'm looking to store multiple blobs into one single record? Do you agree there is a limitation?
Yeah.
Okay. In that case, you might think of using the second option where we store the address or the reference of that particular file which is uploaded somewhere. CDN, local file system, whatever it is, right?
Yes.
Okay. Now, how much access you have to the contents of that file while making a typical SQL query to the database? No access, right?
Yeah.
What that means is if I'm looking to read the contents of some of the files that I've uploaded along with the query, within query, I cannot do that. With the help of query, I can retrieve the reference or the address of that particular file. And then later on, I need to use the file IO to actually get to that particular file and process the contents of that file. Again, that will depend on what type of file it is. That will define what type of file IO I'm going to use and which APIs I'm going to use. If it is Microsoft Office file, probably Office SDK is what I would need. If it is PDF, then PDF APIs will be required. If it is image, I will require some image encoders and decoders. If it is video, again, video encoders and decoders I will require. You get that?
Yeah.
Okay. And what that means is I have dependency on third-party APIs along with the dependency on multiple round trips that happen between the client and the server, right? The first round trip will be between the client and server for the database. With the help of the query, I will be doing that. And based on whatever the results I'm getting with the query, the address part of that row I will read. and then will again perform a round trip to each of the single file that belongs to that particular row. Suppose there are four columns that represents the address of different files. I will be making four different calls to those four different files with the help of different uh, APIs, and then I will be able to retrieve the data, right? So this is going to increase my code complexity, first of all, and reliability would be also the issue in terms of making the data available. Again, the data availability also can be a challenge. I may have database server available, but I may not have my file server available, which is holding the files, which could be possibly the local file system, which could be the CDN as well, or some other storage as well. Got my point?
Yeah.
Okay, so that is one of the major limitation that we had with RDBMS. And the other limitation, which is also important, is how fast we can receive the information which is coming in unstructured or partially structured manner, and how fast we can get it persisted into the permanent storage. Say if we talk about the inputs coming from the web, inputs coming from the mobile apps, inputs coming from say IoT devices, we don't have control on what type of information is going to come, in what structure the information is going to come, and in what format it is going to come. But one thing is for sure needed over here, that as soon as we receive the information, quickly that information needs to be persisted by applying basic validation, input validation rules, right? We cannot actually wait for the transformation of the data happening and then getting persisted into the database. The reason behind that is the kind of sources I just spoke about, like mobile apps or web apps or IoT devices, IoT apps basically, they may be generating the data at such a fast pace that if your application keeps on applying some logic that keeps on running for say a few seconds or more than few seconds, uh, the timeout errors most likely are going to be faced by your clients. Do you agree?
Yeah.
Right. So that is one of the major limitation again that we have with the RDBMS. RDMS would require us to format the data in the way how the RDBMS database understands and then get it saved. Uh, Instead of focusing on just saving the data as soon as it receives. So this is where we require very fast API or fast storage system, which apart from the basic input validations, doesn't do any lengthy processing or transformation of the data, just takes the data as is and gets it stored as is, right? As it is received. And probably to transform the data to make it more meaningful for your application, you might have some background worker processes running somewhere, which might be then reading from the actual storage and then processing it, transforming it, and making it available the way how you're looking for. Doesn't that make sense?
Yeah.
And that is where basically the concept of NoSQL databases come in. The NoSQL databases, I said, provide you different ways, different formats, different structures in which the data gets stored. Like I said, there is document databases which can store data in the form of XML or JSON or BSON, that is binary JSON, which can store the data in the form of object graphs, which can store the data in the form of key value pairs or columnar data as well, right? So depending on the type of information I'm receiving from the client, I would probably select what type of storage is going to be important for me. And that's where, once again, NoSQL database gives you flexibility. There are so many options available, or I would say there are so many products available in the market which provide you the NoSQL storage. And for different formats, different structures, you have different products, right? So you have pretty much flexibility over here. And here, when we say that NoSQL storage is being used, the most important thing is the data need not be coming in structured format. It can be totally unstructured. It can be partially structured information also that is coming. And at times, if required, it can be structured information also. There is no compulsion that I need the data in a specific structure or specific format only. I can receive the data in any format, any structure, and I can get it persisted into the database as soon as I receive it. Got my point?
Yes.
Okay, so unstructured and partially structured data storage is one of the important points. The second point here is we may have the huge amount of data coming in, and that also needs to be persisted pretty quickly. So as I said, it could be originated from web or mobile or gaming or IoT devices, and the pace at which the reads and writes might be happening might actually require the real-time response times in most of the cases. And that means that, okay, even the write operations might be required at the global scale and with high availability also, along with high throughput, low latency, and consistency. Right. So this is where basically the NoSQL databases are going to be required. So how Cosmos DB basically maps to all this? Cosmos DB straight away is a one-stop solution for NoSQL storage. Now, one thing that we discussed about NoSQL storage is we have variety of structures, variety of formats in which the data can be stored. As I said, documents is one of the format, structure. And then within that also we have formats like JSON, binary JSON, that is BSON, or XML, or CSVs, right? And then beside that, we may require different types of structures, different types of formats for different types of applications, and for which we need to depend on different products, right? Like if I'm looking for binary JSON to be stored, the straightforward choice comes as MongoDB. If I'm looking for JSON storage, most likely I would be going for something like document DB, right? If I'm looking for key value pairs, maybe I would go for something like Azure table storage. If I'm looking for some graph storage, I might be looking for Gremlin, right? Different types of products available for different types of storages, right? Now it becomes very complex for us to decide that, okay, which particular product I should be buying and I should be using for serving the needs of my client. Here, if one single product can provide me the storage in different structures and different formats, don't you think this is going to be useful or more useful for us?
Yeah.
As this will make our selection little bit easier. So that's what basically Cosmos DB is doing. The term Cosmos in Cosmos DB comes from a very generic term that we use in our day-to-day life, like cosmopolitan. So when we talk about cosmopolitan, we basically refer to mixed culture, mixed background people living together, and so on, right? And that's where Cosmos DB takes its name from, and which means that, okay, different structure of data, different formats of data can be stored in one single service, as Cosmos DB provides the wire protocols for different types of databases, different structure, different formats, I would say even different products also, right? So that's where we get one-stop solution that, okay, if I'm looking for data to be stored in binary JSON, MongoDB is the format I'm looking for. Cosmos DB provides me MongoDB API, with the help of which I can manage all the information in binary JSON format for all the CRUD operations, right? Similarly, if I'm looking for JSON documents to be managed, we have Cosmos DB API, formerly which used to be called as SQL API or Document API also, right? So we have that. For graphs, we have Gremlin API available. For Azure table storage, we have Table API available, and there are a few more APIs also available like Cassandra and etcd API and all that, right? So different structures, different formats supported by one single product. So product selection becomes much more easier, and based on what exactly is the structure and the format of the data, based on that, I will be choosing my API to work with. But I need to have just one service running for me. I don't need to set up different servers or different services or different products just because I'm looking for storing different structured and different formatted data at different times for different applications. Do you get that?
Yeah.
So just to clarify, like
Yes.
we need to host one Cosmos DB and then we can enable multiple APIs also on the same server, right?
Actually, the instance required would be different as of now.
Okay.
It has been made like that because right now Cosmos DB is not completely interoperable across APIs. Only
Okay.
two APIs are interoperable as of now, that is Gremlin and SQL.
Hmm.
So you can have one Cosmos DB instance working for Gremlin and SQL both, right? But in
Okay.
future, we may see the interoperability between different APIs. But
Okay.
see, as a product, you just need the Cosmos DB service.
Hmm.
Instances you may create as per the need, and there you can map the APIs that are suitable for your application.
Okay.
Right now,
Hmm.
how still it is helping us in uh, case of the NoSQL implementation, or how it is providing a better solution than the individual services for MongoDB or Gremlin or Table or Cassandra or etcd and all that. The thing is, if I'm looking to take my application to the cloud scale, cloud-based deployment I'm looking for, my data also needs to be cloud-based. Here, I don't need to actually search for different services from different service providers. I don't need to depend on Cosmos. I don't need to depend on MongoDB service to be available as platform as a service, or I don't need to set up a virtual machine to have MongoDB server hosted into it and deploying my MongoDB database over there. I can just look forward to Azure providing the Cosmos DB service wherein I just need to select my API. And while migrating my application, because Cosmos DB now also has got MongoDB API, Cassandra API, and so on, I don't need to rewrite my code also. I just need to change my connection strings there. Does that make sense? Your existing investments are going to be saved intact.
Got it.
Okay, so that is how the Cosmos DB service basically help us. Right, so let's see how do we work with Cosmos DB over here now. For that, we need to have Azure subscription, and that I'll access from one of the browser. Here I go to Azure portal, portal.azure.com. I was already logged in, so directly it lands on the dashboard. And here, the first thing I'm going to do is create a resource. In fact, I'll start with a resource group. So let's go to resource group and say add. Select the subscription. You may have more than one subscriptions in place, mapped to the same account. So carefully choose which subscription you are going to use. I'll create a resource group by the name DemoRG, and the location, the region, I'll select as Southeast Asia. This should be based on where your audience is going to be. I mean, the users of your application are going to be. Okay, so next, tags are basically for applying some metadata for any of the resource or resource group that you deploy, so that you can identify that resource group or resource easily across different projects. As of now, I'm not giving any metadata here. Just say next and click on create. So this should be almost immediately done because the resource group is just a container to hold different types of resources and manage those resources centrally. So it directly gives me notification here, resource group created. I just click on go to resource group. Okay, so here I can see there are no resources as of now in this resource group. Here I can add any resource by using this add option directly available under resource group, or I can make use of the main menu option that is create a resource. So I go for create a resource. what I'm looking for is a Cosmos DB service, which is a database service. So I'll go for databases, and there I'll look for Azure Cosmos DB service, which is here. Let's click that. So Cosmos DB creation configuration comes up, and here once again I need to select the correct subscription. Resource group, this time I'll select the one that we just created. If we have not created, we can actually create one by using create new option here as well. And then I need to give a account name over here that needs to be globally unique, as the name that we use here will be treated as a subdomain in a pre-created domain on Azure. So I call this as OI demo Cosmos Let's see if it is available. The green tick mark here shows that it is available. And then here I need to choose the API. Once the API is chosen over here, you cannot actually change it. So Cosmos DB API is actually also called as Core SQL. A lot of renames happening here. So sometimes you will find document DB API in some documentation. Some will say SQL API, some will say Cosmos DB API. And now here the portal is using the term as Core SQL, but these are all the same. The other options that I have here are Azure Cosmos DB for MongoDB API. If I'm looking to have a MongoDB based application to be connected to Cosmos DB, I'll choose this. Same thing goes for Cassandra, Azure Table, and Gremlin. etcd is also there, but that actually depends on which region you have selected for the deployment. This availability of APIs is depending on the region, the data center that you have chosen. So for now, anyways, I'm going for Core SQL, and I select this. Then we have another preview feature coming in, notebooks, which is basically a feature that will be required if you are going to integrate the Cosmos DB data with big data services. So for now, I'm just keeping it off. No big data stuff I'm looking for as of now. And then comes the location, where I say my location is going to be Southeast Asia, same as what I've selected in the resource group. Okay. The limit on the amount of data that you can store over here is actually unlimited. So practically, there is no limit on how much data you can store. Let's see, after changing the region, if we have got some update here. Okay, Southeast Asia is also not supporting etcd. You have to check which region basically supports that. That's a recent entry actually here. Then I go for the offer coming over here, free tier discount. So anyways, this is a demo session, so I can definitely use this. You can have the free tier discount applicable only for one Cosmos DB service deployed in your subscription, and you will get 400 request units and 5 GB storage for free without paying anything. You can have 5 GB of data stored into this account, and 400 request units will be applicable. Now, what request units over here means? It's basically a throughput calculation based on the CPU usage, the input-output operations, what we call as IOPS, and then how much memory that is going to be used, and finally how much actual storage is going to be used. So based on that, the calculation is done for the request units. You can look for more on request unit calculation in Cosmos DB account documentation, and there you will get to know how it is actually calculated. One request unit means what? Anyways, there is no fixed number over there because it depends on 4 or 5 different parameters. So always it will be a calculation based on all the 4 or 5 parameters. Right? So that's why there is no fixed number that one request unit means this much of data and this much of IOPS I'm able to do. Sometimes the data might be more, but IOPS may be less. Sometimes IOPS may be more, and data may be less as well. Okay, so this is what the limit that we have per month. So by default, it is giving us the estimate of $24 per month discount per account. So I say apply, then I go for account type, production or non-production. It all depends on, I mean, the selection basically here will make difference only on the options that will be available post deployment. So here, after toggling this account type from non-production to production, you can see the geo redundancy and multi-region rights are by default getting enabled, which is not the case with non-production here, though I can manually enable them if required. So basically, non-production is something that you will be using when you are just developing the application and probably testing the application. Till staging, you may use non-production, and then production will be the live database. Redundancy, you may require once you go live. In fact, right from the staging, you may require the geo redundancy. This is for high availability, and multi-region write sits on the top of that. By default, Cosmos DB account, even if geo redundancy is enabled, will allow you to read the data from multiple regions, but not write to multiple regions. That's where multi-region writes comes in. When you enable multi-region writes, Cosmos DB account will allow you to write the data to multiple regions as well, wherever your deployment has happened. And the same thing goes with availability zones as well. Right, so all related topics. And if you enable them, definitely the cost is going to increase. So if you say geo redundancy is enabled and there are two regions configured, so there will be double cost. Similarly, multi-region writes depends on how many regions are there. Availability zones depends on how many zones are there. Right, so those many number of copies will be there, and hence your cost is going to be increased accordingly. Let's click on next. This is important, where we will be whitelisting or blacklisting the IPs which can communicate with your Cosmos DB account. This is pretty much the same thing that you see with storage accounts or even the SQL Azure service as well. If I select the connectivity method as all network, that means unrestricted access from any network from anywhere. I can connect to this service and interact with it and manipulate the data. If I say public endpoint selected network, that means I need to go and select the virtual network which will be allowed to interact with this Cosmos DB account, right? So only the whitelisted networks will be able to communicate. If I say private endpoint, in that case, I need to create the specific VPN connectivity here, and where I need to whitelist the IPs one by one. Say, for example, here, if I say my current public IP needs to be whitelisted, I can say allow, right? And then I can proceed. So for now, I'm keeping it all networks. The next section is about the encryption, how the data encryption is going to be managed, whether it is the Azure service that will be managing the key. Automatically, the Azure services will be creating a managed key, and using that key, the encryption will be taken care of. If your client's policy says that no, we will be creating our own keys, we will be managing our own keys, and we'll be using those keys only for the data encryption and decryption, then you go for customer managed key. In that case, that key needs to be first of all uploaded to Azure Key Vault, and that URL of that resource in the Azure Key Vault needs to be provided over here. So for now, I'll just say service managed key, as we have not created any key, and we have not created any Azure Key Vault instance as well. So just click on next. Tags I'll just ignore. So again, click on next. And once the validation is successful, we can say create. Any questions meanwhile? This is going to take some time. So instead of waiting for the deployment to finish, what we can do is we can go to Visual Studio and start preparing our console application based on .NET Core. So here I have Visual Studio 2019. Select create new project option here. Wherein using filters, I have selected C# as the language, all platforms as the platform selection, so that it gives me cross-platform application that can run on any of the platforms listed over here. If I select Android, it will run only on Android. If I select Azure, it will be a cloud application. If I select iOS, it will be iOS specific application and so on. Right, so I select all platforms and then here I select desktop. That gives me console application. I should have console option also. So I click on console here and there we have the console app.NET Core. It says that it's a console app based on C# and that can target multiple platforms. So this is what I was looking for. I'll just select this and click on next. Let's name this project as DNC_demo Cosmos DB. Location I'll put on desktop and click on create. Okay, so there it comes with the console application based on .NET Core. The first thing that I'll do is remove this console write line statement. I don't need this. And I need to prepare this application for talking to the Cosmos DB account using the Cosmos API or Core SQL API. For that, I need to go to Tools, NuGet Package Manager. I have two choices. If I'm comfortable with commands, I will go for Package Manager Console. If not comfortable with commands, I need GUI, then I'll go for Manage NuGet Packages for solution. So for now, I'll go for Package Manager Console. Using CLS command, I
Just
just
a
get it
question.
here.
You would be
Yeah.
providing the recording for this particular training
Yes.
session? Or
Yes.
oh, okay.
Yes, it will be shared. The command is install package. Azure.cosmos. This is for working with Core SQL API. If you are looking for MongoDB, there is a different package. For Cassandra, there is a different package. For Gremlin, there is a different package. For etcd, there is a different package. For MongoDB, again, there is a different package, right? So depending on which API you are selected while creating the account, you can install the package. For this package, I'm looking for a specific version, the latest one, which is still in preview, in fact. That is 4.0.0 hyphen preview 3 and press enter. The single hyphen here. And it's installed along with all its own dependency packages as well. The next thing that we are going to do is import couple of namespaces on the top of this program. So I'll say using system.text.json and followed by system.text .json.serialization . And here I'm going to create some classes, which will be our data that gets stored into the Cosmos DB account. So I create a class over here that is public class named as address, which has got few properties. First one is of type string with the name state. Oops. Next is and there is one more in between, that is county. Then I have a class called as parent, which has got a couple of properties into it. Again, string, family name, followed by string first name. Then I have another class called as pet, which has got a single property into it. String, let's say, given name, followed by another class over here named as child, which has got few properties into it. The first one being string family name. Next is string first name. Next is string gender. Next is int grade, followed by a property of type pet array, where pet is this class that we have created here by the name pets. And then finally we have another class named as family, where I have few properties. First is string ID. Next is string last name. Next is parent array named as parents. Next is child array named as children, where parent and child are the classes that we created before this. Then we have another property of type address named as address. Then I have another property of type boolean, so bool, named as is registered. finally, I override the toString method over here to return the JSON representation of the object on which toString is called. So for that, I just use JSON serializer, serialize method, and pass the current instance of this class whose JSON representation will be returned. Because we are working on console application to provide the output in JSON format, we have used this. Okay, so this is all payload information that we have created. Something like entity classes that we would be creating while working with entity framework that uses some RDBMS database in the backend. Though here the structure can be decided purely based on what data is coming from the client side. I can make this more dynamic. Though right now I have given a pre-provided structure, but it's not mandatory always. Next thing I do is I import another namespace over here by the name of the package that we installed, which was Azure.cosmos. I'm also going to need some other packages or namespaces from here. So the first one is system.collections.generic. Provide some collection services. I'm going to need system.net. Provide some network services. I'm going to need system.threading.task to provide async operations using task parallel library. And then let's move down to our program class. Here at the class level, I'm going to define some static variables. Let's say private static string let's see if the deployment has finished. Yes, it is. I can just go to notifications and click on go to resource. I'm going to need some information from here. So in this settings section, I have a category named as settings, under which I have some setting named as keys. I go to keys, and here we have the connection string information available. So we have a couple of connection string. One is the main connection string. The other one is backup. If the first one fails, connect to the second, just like having two different endpoints to the same service. And this can be useful even if you think that your primary connection string has been compromised, and because of that you have regenerated, so your application will still not fail, as it would be having the second connection string as well. Right. So you can switch your application to second connection string and straight away regenerate primary connection string. You have read-write keys and you have read-only keys. So depending on what kind of access you are going to provide, you have different types of keys available, different types of connection strings for that same method. Right. So here I go for read-write keys as of now and take only primary connection string because I'm going to be the only user connecting, and hence there is no issue where the key can be compromised or where the connection may not be available because of too many users. So I just go for primary connection string, go back to Visual Studio, and here I use the string as by the name connect string. I create this variable and assign my connection string there. Okay. The next thing that I define over here is another variable, static string DB ID, that is database ID. I call this, I assign the value to this DB ID with the name as family database or family DB. I define one more static string variable here. By the name container ID, which I said is equivalent to tables in SQL Server or any RDBMS. I'll call this as family container. Okay. In main method, I create the instance of an API provided by Azure.cosmos namespace by the name Cosmos Client. This is like proxy class or proxy service available to interact with your Cosmos DB database. So let's say Cosmos Client is the name equals to new Cosmos Client, wherein I need to pass connection string. The other overload takes an endpoint and key separately. As we have got connection string, I'll just pass the connection string here. Okay. I've hard coded this, but you can actually put it into config file, or you can put it into the Azure Key Vault, and from Key Vault also this can be obtained. Next, we need some helper methods to be created here. So let's start with our first helper method. That looks like private static. I want this to be a synchronous method, so I say async task create db async. That's the naming convention. If it's an asynchronous method, the name needs to have the suffix of async, and it needs to have a return type as task. Only task means it's a void method actually. If it is task of something, in that case, what you pass as the type parameter to the task class is actually the return type of your method. Here I take in the parameter of type Cosmos Client by the name Cosmos Client, and there goes the body. Wherein what I'm looking for is an instance of the class Cosmos database to be created by the name db equals, instead of saying new Cosmos database, I'll take the help from the Cosmos client to get the database created for me. So here I say await Cosmos client dot create database async. This will forcefully create the database. If database already exists, we will be thrown with an exception. So if you don't want that exception, you want smart work here, like check if database doesn't exist, created. If it already exists, just connect to it. In that case, you have to use the second option that we have here in the IntelliSense, that is create database if not exist async. Let's select this and provide the parameters to it. Like, first of all, it is asking for by what ID you want to create this database. So for that, we already have created a variable in the global space that is dbid. I'll just pass that, and it will create a database by the name family db. Inform the user, as it's a console application. Will inform the user by console write line statement that says database created. And I want to show the database ID over there. So here I say db.id gets displayed. And here I want a new line also. Okay, let's call this method here in main. Create db async. And pass this Cosmos client there. This is an asynchronous method. So what I'm looking for is until and unless this method doesn't get completed, it should not move on to the next line of code. Hence, I put await there. Now, to make use of await, the method containing await also needs to be defined as async. What that mean? Here I need to say static async. Instead of void, I need to say task main. Okay. And let's test this application. So I'll just say Control F5. Just wait for database created option. And here we get the option, database created family DB. I close this, I go back to the Azure portal, overview tab. Containers, it is showing, but there is no database context displayed here. So no issues. We can directly click on Data Explorer here, or we have Data Explorer option here as well. So click either. And here we get the welcome to Cosmos DB page, and on the left hand side, it shows that we are using Core SQL API, under which the family DB database has been created. Is it clear to all? Any questions so far?
No.
Okay, let's proceed and see how do we create the container now, which is equivalent to tables in RDBMS. So let's switch back to Visual Studio. We'll have another helper method created over here for creating the container. So once again, I started this way, private static async task, method name as create container async. This also takes in Cosmos client as the parameter by the same name, Cosmos client. Now I want to create a container here. So for that, we have Cosmos container class. We'll create the object by the name container, and we'll say Cosmos client. Once again, I'll use, which provides me a method called as get database that takes in database ID as the parameter. So the point is I need to create the container in that family DB database only. So I first need to obtain the family DB database context here. So get database will give me that. I can hard code the value, or I can directly pass DB ID parameter here. And then I say dot create container async. What it is asking for is the ID for the container followed by the partition key path information. So here the container ID that we have defined as a variable, we will use that. And then comes the partition key. Now what is partition? It's not a new feature. It was there in most of the RDBMS databases also. So anyone knows about it? What is partitioning and what it is used for? Yes, anyone?
No.
No.
So suppose if I'm having huge amount of data that needs to be stored into the table, or for that matter, here we will say container, the retrieval of that data would be very slow if that data is stored as one bunch of the data directly. Do you understand that or not? Because I need to read one big file in that case. Yes or no?
Yeah. Obviously,
in this
reading from the
case,
small files.
yes. So this is where we need to split that data into multiple files or multiple storages. And there Based on whatever the criteria that is coming into the query, we can select which particular fragments needs to be actually scanned and which fragment need not be scanned, and read the data only from the required fragments. Do you think that will make the retrieval faster?
Yes.
Great. Now this is where we need to decide what will be our partition key, and that's what we are going to pass over here. You have to thoroughly analyze your data, and there you have to see that, okay, this particular field is going to serve the need of the partitioning for this application. So for example, if I have customer information being stored, probably the zip code or pin code I can use as the partition key. If I'm not using pin code at all into the storage, I may still have the city or district or something that can become my partition key. I need to use little broader scope there, right? And that's where basically the storage is going to be decided. So here I say, I'm going to use the field last name for my partitioning. So based on what last name I'm passing, all the data for the users having the similar last name will be stored in one physical location, one physical device. And for different values of the last name, the different groups will be created, which will be stored on different storage devices or different hardware devices, right? This is async method, so I need to put await keyword over here. Okay. Then I inform the user that, okay, your container has been created. Once again, I'll use console write line statement where I'll say container created with container ID displayed into it. So I can pass the variable container ID followed by new line character. Okay. Let's
So
call this
last
method
name is
also.
acting like a indexing value or something?
We can say the partition value. So based on, say, if I put three names into the database, the first last name is, let's say, Karnik. The second last name is, let's say, Joshi, and third last name is again Karnik. The first and third record will be put into one same storage location, same physical storage location in one single file, whereas the second one will go to a different one. So you can say this acts as the indexing key also, but not for retrieval, mainly for storage.
So there may be more than one partition key also or not?
No, here we have only one partition key allowed at the top level.
Okay.
Rest of the indexes are managed automatically by your Cosmos DB service. You don't need to create indexes at all. Based on what kind of queries are coming in, automatically the Cosmos DB engine tunes your database and creates the required indexes for you. Make sense?
Yep.
Okay, so here we call this method and let's test this out. Control F5 once again. I should get two messages now, database created and container created. Oh yeah, I didn't put that statement. Await create container async, to which I pass Cosmos client. And one small change here also, I'm going to use create container if not exist async instead of create container. Because if I run the application twice, second time it is going to throw the exception because the container would already exist. So conflict exception will be there. Okay, so here we go and say Control F5. So there we get the messages, database created, container created. Let's go to the portal. And we have a refresh button over here. Let's click on this. I can see the container also got created here. If I click on items, it won't show me anything because we have not added any data as yet. And the other things we can see is we have the scale and settings option. right? By default, it has been configured for 400 RUs. And then we have manual scale configured. If we want it to be auto scale, we have to select this, but that comes at a cost. As we are in free tier, we should be actually not changing this. Time to live, you can go for off or on or whatever it is. Then geospatial configuration, you can set that as well. Then you have the stored procedures, user-defined functions and triggers also supported, just like SQL Server or SQL API. MongoDB may represent something else. Well, just click on items as of now. And let's switch back to console, close it, switch back to Visual Studio. Now what I'm looking for is some data to be added. So here I'll say there is another helper method coming in, private static async task add items async, which also takes in Cosmos client as the parameter by the same name, Cosmos client. First thing I do here is I create the instance of the family class. Let's say family, Anderson family. Equals new family. I use object initializer to get it initialized. And I proceed with ID equals to, let's say, Anderson dot one. Before I proceed further, there is a small change I'm going to make in the family class. Here on ID property, I'm going to put an attribute that is JSON property name. And there I'll pass ID with small I. Any idea why I did this? Seems to be similar to what we do in entity framework also, right? We use column name property.
Yeah,
Right.
overriding
So
column.
so what happens here is if you don't give this, behind scenes, Cosmos DB is going to have ID property defined with this name. Along with that, it will create one more ID property with this name. Okay. Now, this will be user defined ID and this will be system defined ID. Now, what I'm looking for is I don't want to have two different IDs, user defined and system defined. I want just one ID to be used. That is system defined one only. That basically is the unique value for my ID. And then that needs to be mapped to this field ID. Okay. And because now it is available as a property over here, I can actually decide that what will be the value instead of letting the system generate the value for it. I want user generated value to be used. So for that, I did that mapping. Now let's set other properties over here. Next will be last name equals Anderson. If I put one more record by the last name Anderson, it will go in the same partition, right? Then I go for setting up the property parents to new parent array. Using array initializer, I'll get elements added to this. So here I say there are a couple of elements here. New parent with object initializer, I just set first name property there to Thomas, comma, other parent object, first name as Mary Key. K. Next, I go to the family object, and here I set the property children to new child array. Again, array initializer comes in, where I just say there is only one element, new child. I use object initializer here as well, where I set first name equals Henriette. Paulo. Gender as female. Grade as 5. Is the next property equals to new pet array. Where I have single element, once again, new pet. With the only property given name being set to coffee. So that's my child property, and then children property complete, put comma here, and then let's set the address to new address, where I have state as WA, that is Washington, county as, let's say, King, and city as, let's say, Seattle. This data can be anything. Here I say is registered equals to false. Okay, so here the object is created for family class. Couple of ways we are going to see how do we insert the data, different strategies in fact. So the first strategy is a bit lengthier one, and the second one I'll show you the easier option as well. So once this object is created, here I go for defining an object of Cosmos container. I need to receive the container information just like how do we receive the database earlier while creating container. So I say container equals Cosmos client dot get container that takes in database ID and container ID as the parameter. And there I pass DB ID, comma, container ID, variables. Okay. So that gets the reference of the container object. Next, I go for creating an object of type item response. But see, while inserting the data, if the data is duplicate, there could be a failure as well. So I go for try catch block, where I'm expecting an exception of type Cosmos exception. I'll capture it in X object. And let's code for try first of all. So first thing what I'm looking for is I'm looking for checking if the item that I'm looking to insert already exists. Right, and if already exists, inform the user that this item already exists. If not, then the exception comes, and in that case, I want to get that record inserted. So here I go for defining an object of type item response of type family I'm looking for item response of type family. Object name is Anderson family. Response that is equal to container dot read item async. Which type of item I'm looking for? It is family again. So I put family in place. And then the parameters for this method, read item. What it is asking for is the ID. So here I say the object that we have created on the top, Anderson family.id is the ID. I'm looking for an object by the ID that is Anderson.1 in this case. Next, it is asking for is the partition key information. So here I say the partition key is specified by new partition key, and into the constructor only I'll give the value for the partition key. So which is Anderson family, again the same object from where I got the ID. I'll say last name. And because this is async method, I need to say await is used here. So finds the response. If the response comes, in that case, it gives me the data. If the response doesn't come, in that case, it basically has to generate the exception. So for that, I need to do something where I need to actually try reading the value from this object Anderson family.
Hello, I'm not able to hear you. Are you speaking mute?
So here I say item in database with ID Anderson family response dot value dot ID. If there is no object, in that case, reading this value dot ID will result in an exception, and that will take us to if we go to the catch block, we want to insert the record because it doesn't exist. Now here the exception might come with different reasons, and that's where basically what I'm looking for is don't capture all the type of exceptions like null reference or something. I want some specific exception to be caught here. So I put a conditional statement here using when. When, here goes the condition.
So basically, if there is no response, the Anderson family response object would be null, right?
Yes, yes. So reading this Anderson family response dot value will result in an exception.
So in the ideal scenario, there should be an if else put up place. That's why
Correct.
I'm asking, like Anderson
Yes,
family
yes,
response would be null. Okay.
yes. So again, the Cosmos DB over here works with RESTful APIs to operate on it, and that's where the exception also is returned in the form of HTTP status code, and which I can check over here, like where I say when x.status equal to HTTP status code dot not found. Now this is an enum, and it may not get compared directly with this status value because status is int and not found is going to return maybe long or something. So here I explicitly typecast it to int. So I'm looking for a specific exception which says that, okay, the record is not found. So I hope that also answers your query.
Yep.
Okay. So in that case, what I'm looking for is go and insert this record. So here I say item response, again of type family. I name this also as Anderson family response equals container dot. Container should give me the option for adding the record, either add or insert or maybe create. So let's say if we have add, no, directly it shows me create item async. I go for this create item async of type family. And what it is asking for as input is the family item, where I can directly pass Anderson family, comma. Next it is asking for is the partition key. So I can simply say Anderson family dot last name is the partition key value. Error because I guess this is not asking for a string. I'll just get this cut from here and let's check. It is asking for partition key object. So here I need to say new partition key, and into the constructor I need to pass Anderson family dot last name. Complete the statement. Now why error? Because this is also async. I need to put await here. Then only I can assign the response. So whether successful or not, the Anderson family response object is going to let me know whether the operation for insert has been successful or not. Okay.
Yes.
So here I say inform the user the object is created. Item created in database with ID and that ID is Anderson family response dot value dot ID. Okay. Let's call this method here await add item async, which I pass Cosmos DB client and let's say control F5. It says item created in database with ID Anderson 1. Let's go to the portal and refresh button over here. I will use this time and I can see there is some data. So by default, it shows me only ID and the partition key. I just click on this and here it shows me the complete document generated. Do you get that?
Yep.
Great. Let's go back to console, close it, go back to Visual Studio, and there is something more to be added to this add item async.
Could you go back to Azure portal? I had one question actually.
Yeah.
So the family container is the container, and that is like a table or something. Can we say it's similar
Container
to?
represents the document container, and that document container contains documents. So yes, you are right. Container is like a table, but table contains rows and columns into it.
Yeah,
Here the
obviously.
container contains documents.
Okay. So each and every row would be a different file then,
Uh,
right? Container. I'm
Actually,
just
storage
trying to
wise,
figure.
no. Storage wise, no. It will be stored into one single file only, but
Okay.
can be represented as a separate JSON document.
Got.
Okay. Hierarchical document will be created. You can have multiple documents returned also with the help of one single query.
Okay.
Yeah.
Okay.
Okay. So let's go back here to Visual Studio, and as I said, there will be two different approaches to add the data. This is the lengthier approach that we have seen. first try to read if already exists or not. If exists, show exist, and if not, then the exception for not found is caught, and there we have the insertion operation. Correct. Now let's have a look at a different approach where once again I'm going to create the family object for a different family. Let's say Wakefield family equals new family. Here comes object initializer. I set the ID first over here to, let's say, Wakefield 7, comma, last name. You can guess it should be Wakefield. And parents equals new parent array. Here goes the first parent information. I say family name is Wakefield. First name is Robin. In first case, I didn't use family name for parent. Here I'm using one. So here I say new parent, family name, let's say is Miller. First name is Ben. Children property set to new child array. There goes array initializer. I say there is new child instance with family name being set to Miriam. First name Jesse. Gender female. Grade eight. Pets, new pet array. Here comes array initializer for pets. New pet. Given name equals Goofy, followed by another pet. Given name equals, let's say, Shadow. Then another child object I create here. Where I have family name as Miller. First name as Lisa. Gender female. Grade 1. No pets this time. Finish children array. Then I proceed with address. New address. With state as NY, that is New York. Say Manhattan. and city as in Y, again New York, followed by comma, followed by is registered. This also set to false to start with, and the object is created. Next, the logic for adding this record to the database. So unlike what we did earlier, I'm not going to check whether it already exists or not. I just use a different mechanism or different methodology here. Anyways, it is going to need item response object where the detail whether the operation got successful or not will be placed. So I create item response of family type by the name Wakefield family. Response equals container dot, like create, we have a method called as upsert. So update if already exists, otherwise insert, that is upsert, right? So it automatically check if the data already exists or not. If already exists, just update that data in place. If not, then create or insert. Okay, so what is the object that needs to be created? It is Wakefield family, comma. The next thing it is asking for is the partition key. So here I'll say new partition key, to which I'll pass Wakefield family dot last name, just like what we did earlier. Complete the statement, and this being async method, I need to put await here. And then inform the user that the data has been inserted. So item created in database with ID that is Wakefield family response dot value dot ID. This is much more better option. Instead of explicitly checking, let the system check whether the data exists or not. Got it?
Yes.
Okay. Let's save and say Control F5 to test this out. So this says that okay, it is already there, and then the new item has been created for Wakefield. Let's go to the portal and click refresh here. I should see 2 rows here, which I am able to. I click on this and I am able to see the other document as well.
Yes.
Got it?
Yeah.
Okay.
If we run it again for the second line,
Let's try that. No issues. It just takes in the values and rewrites those values, overwrites those values. So
Okay.
again, if I go to the portal and say refresh, I still have 2 records only.
Okay.
So upsert is update or insert. Update if exist, insert if not. Clear?
Yeah. And if we want to access the historical data also, like ID can't be multiple, right? So,
Yes.
like if we want to see a history of data, that option is not there then.
You mean the versioning part, right?
Yeah.
Yeah, by default, it's not there. If you want, you can actually have your additional logic created for that.
Okay.
Okay. Okay, so that is add item stuff. Now let's see how do we query the items. One of the way how to query the item we have already seen, but that was not based on the query. It was more of a direct access to that particular record
Can we
where we
just
use
take 5 minutes
read.
break before we move into read part?
Yeah, sorry, come again.
Can we take 5 minutes break before we move on to read part?
Yeah, sure,
Okay.
sure, no
Shall I
problem.
be on the this? You will be on the this meeting only, right?
Yes, yes,
Okay.
yeah.
You can resume this. I think you are speaking on mute. I'm not able to hear you.
Yeah, I just changed my microphone actually. The earlier
Oh,
one had some trouble. So maybe because of that, by default, I went. Sorry. So we were talking about the read operations, and there we saw the read operation where we directly pass ID and the partition key. So it was more of a direct access. This is not something what we can say is a query. Within query, I should be able to put in multiple criterias, not only on keys and partition keys and all that, but other fields also, right? So that's what we are going to see in this part. And for that, again, we will have another helper method created. So let's say private static async task query items sync takes in Cosmos client, just like other methods by the name Cosmos client. First thing I'll do is define a string named as SQL query text. In the beginning of the session, we rightly said that Core SQL API allows you to use SQL query type of query statements to query the data from the Cosmos DB. MongoDB has got its own way. Cassandra has got its own way. So depending on the API, the operation will be implemented. So here I go for a very known syntax. Select asterisk from C. This is where I don't mention the table name or container name directly. Here C by default is the container on which this query has been executed. So dynamically it retrieves the name. Where C dot last name is what I want to query. And I'm looking for the last name to be Anderson. So if I execute this query later on, it is going to return me all the objects where the last name is Anderson. And that this is where, once again, because it is putting the criteria on last name, which is partition key as well, it will scan only one partition there where the partition value is Anderson. Right? If I query on some other field, in that case, within all the partitions, it is going to search for the data. So that's why selection of the partition key is very important. Let's say console right line, display the query first of all as it is on the console that we are going to run this query. So the text is running query. Wherein I pass SQL query text. So query gets displayed as it is. Then I create the instance of Cosmos container by the name container. How do we create this? Not by using new, but by using Cosmos client. So we say Cosmos client dot get container and a couple of parameters, database ID. So DB ID goes in, comma, container ID goes in next. Then I create an instance of query definition. This is the object which is somewhat similar to SQL command in SQL client provider. Right. So I'll say this is query equals to new query definition, to which I just need to pass the query text. So I'll pass SQL query text to this. To capture the data later on, I prepare a list object of type family. By the name families, I define it and I say new list of family. And then here I go for each where family in container dot, there is a different method now. Instead of read item, we have something called as get item query iterator. And this actually gives me the iterator on all the documents that have been written. So what kind of documents I'm looking for is family, and I need to pass query definition object to this. So I pass query, and because this is also an async operation, I need to prefix for each with await. And then I just say families dot add. It will be directly returning family object. So I just pass family here on which the iteration is happening. And at the same time, I'm looking to get this document displayed. So here I say /t red, within curly brace, I pass family object. And /in at the end. So this is the read operation. Let's see by saying Control F5. We'll run this again. And this time on console, I need I expect the JSON document to be displayed for Anderson family. Yeah, we have not called this method in main. Sorry about that. We'll just include the call to this method here in main. Run again. Okay, so there we get the JSON documentation completely for Anderson family. Only one record is there, so that's why it's showing one. If there are more than one, all will be displayed basically. Is it clear?
Yes.
Okay, now let's see how do we update the item. One is upsert operation, but then there is another way also using which we can update the data. Read first of all, then modify the values, and then once again replace. So we have a method called as replace item async, and that's what we are going to see here in the next helper method. So private static async task replace item async, taking in the same parameter Cosmos client, in name Cosmos client, and here also we first of all get the container reference. So maybe I can just copy this statement as it is going to be the same. Get the container reference, then create the item response for Wakefield family. We'll say item response of family type Wakefield family response equals container dot read item async. That's the same method we have used earlier for insert operation of type family. looking for the ID and the partition key. This time I don't have a pre-created object, so I just hard code it to Wakefield .7 and new partition key, that is Wakefield. This needs to be same as what we have passed over here. Wakefield.7 and Wakefield. Complete statement and put await keyword. Now we got the object which has been already put into the database. What I'm looking for is to change the value here for the object that is retrieved. So here I say Wakefield family response dot value dot is registered, which is false. As of now, I'll set to true. We can check that on portal. For Wakefield is registered is false, right? So we are making it true. And then I say Wakefield family response dot children, in fact dot value dot children, first child, basically the grade I'm looking to change to, let's see what is there by default. It's 8 by default here. I want to change it to 9. Okay, so updated data is now there in Wakefield family response. Then I say Wakefield family response equals to container dot replace item async of type family. For family, the updated object, I'll say Wakefield family response dot value is the updated object. Comma, the partition key, if it is also updated, needs to be passed along with ID as well. So here I say comma, first I pass the family ID, which will be Wakefield family response dot value dot ID followed by the partition key. So again Wakefield family response dot value dot family name, last name in fact in this case. Complete the statement and put await keyword here. Yeah, this needs to be passed as parameter to the constructor of new partition key. It doesn't take it on its own, so I put it that way. Next, inform the user that your item has been updated. So console.writeLine family updated. Some data I want to display about that family, where the first item is the last name. So here I say Wakefield family response dot value dot last name, and then I want the ID itself to be displayed. So Wakefield family response dot value dot ID. some more text with new line character. And the updated data also I want to display. So here I say body is now. Wakefield family response dot value. Okay. So that's how we update the records. Let's say call this method in main. So I'll put await, method name, pass Cosmos client, and control F5. So here it shows the updated values is registered. It has taken as true, which was false earlier, and grade also has become 9, which was 8 earlier.
I think
Okay.
this is the first read. After updating, we
Yeah,
didn't run the
yeah,
read.
yeah. But we can test that on.
Yeah, it would be.
So here we have 8 and is registered as false. This is the old value for Wakefield. Just say refresh here. Click on Wakefield 7 and I see this is true now and grade is 9. Yes.
Yes.
And then let's see how do we delete the item. So for that we'll have another helper method created. Private static async task delete item async that takes in Cosmos client. I need the container once again, so I just copy this container statement here. I create item response of type family to capture the data which is deleted later on. Say Wakefield family response equals container. Directly I have a method called as delete item async of type family. What it is asking for is ID and the partition key. So ID is Wakefield 7. And then the partition key is new partition key and the value is Wakefield. Locate that item and get it removed from the document. And here I say await. Inform the user that item has been deleted. So console.write line item deleted. Let's call this method in main. And control F5. It says item deleted. Let's see on the portal. Here I'll say refresh. Wakefield family record has been deleted. If I want the overall stuff to be refreshed, I have to click refresh here. Oh, complete browser needs to be refreshed. There is no close button, unfortunately, for this pane. So maybe we can just close this tabs over here, and then we go to family container, items, and now it is clean. Clear?
Yes.
And now the last thing, how do we delete database? How do we delete the container? So if I delete database, container anyways gets deleted directly, but we have delete container option as well.
So, so that is the last topic you are planning to cover?
Yes,
Actually, 1 second. I think that we can look at. Could you cover this thing? The stored procedure, user-defined functions, triggers, like.
We have planned another session on that,
Okay.
stored procedure, functions, and triggers, because right now the time is not going to be sufficient for going
Yes.
through
Hmm.
all these things. So in fact, next week I'm planning to have a session on that.
Okay.
Okay. So just wanted to keep the webinars very short and crisp, so
Yes.
that relevant topics can be attended by people. So here I say delete DB async. Cosmos client. I get hold of Cosmos DB. So Cosmos data instance I'll create. DB equals Cosmos client dot get database. Database ID needs to be passed, so I pass DB ID. Likewise, you have container deletion also. You get the container and then say delete container. Okay.
Yes.
Here I say database response. So for containers, you will have container response. DB response equals P dot delete async. Delete for deleting container, we have delete container as well. Just put await and there we go, and display the message that database has been deleted. Deleted DB. DB ID. I can take it from DB response also. So DB response dot value dot ID. Okay.
Yes.
Call this method. Pass Cosmos client and control F5. That item deletion basically gave the exception because that item doesn't exist anymore. So probably I can just comment this out, the second last statement, run again. We didn't check whether it is there to be deleted or not. So exception is okay. I guess it already deleted that. Let's see on the portal. Yeah, it already deleted that first time itself. That's why this time exception. Is it okay?
Yes.
Great. So that is it for the session. If you have any queries, please feel free to ask.
Like can when we go ahead and read the data, is it include like we can run all the types of SQL query like join and all or not?
You can actually, because it is formatting the data accordingly, and join is not like what we used to do in SQL Server, because the data being returned is JSON format data. You have to build a JSON document. So Join are possible, but in a different manner. You have
Like
different statements for that.
like after getting the two different objects, we need to perform our own join
Yes.
in the programming. Okay.
No, there is join operation also available within query, but the syntax is different.
Ah, syntax is a different. Okay.
Okay. So these are my contact details. If you have any further queries later on while working, you can get back to me. You can mail me on that given ID or you can WhatsApp me on the given number. I hope you enjoyed the session.
So thank you for the session.
Just 1 minute. I'm sharing the feedback link. Please spare 1 minute for the same.
Okay. And could you send me the code which you have written in C#?
Okay. Let me package that and upload that to my OneDrive link.
Okay. Here is my email ID. I'm just putting it up in the chat.
Yeah, no problem. So in the chat itself, I'll put the feedback link also. Hardly 1 minute required. Just fill the feedback.
Sure, I'm just filling it right away. Thank you for the session.
Thank you.
Bye bye. Have a good day.
Bye bye. Thanks.